The screen is not visible. And now it is visible, sir. Now it is visible.
Okay. So we will continue collision for today.
Yes.
So already we have done these case. So when colliding bodies are moving in opposite direction, then again the same thing. You will first of all write the equation for conservation of momentum. And we have assumed that this collision is perfectly inelastic. Perfectly inelastic. So when it will be perfectly inelastic, both the bodies will stick together and they will have a combined velocity, common velocity. In this case, always there is loss of kinetic energy. This is the loss of kinetic energy, initial minus final. Is it clear? Go through this slide and tell me is it clear? Tell me.
Yes.
Is it clear? Not clear?
It is clear, sir. Yes, sir. It
Okay.
is clear.
So then let's go to the next. Now, you can try this question. Very simple, basic. Try this one. Tell me, got the answer?
Sir,
Yes.
so here we cannot define, sir, which is it depends upon velocities and everything, sir.
No, does not depend on velocity.
Yeah.
Means why you think it depends on velocity?
Sir, one capsule. So striking of yes, sir. Because the momentum is conserved, sir.
Hmm.
You can say
Here
it
all
is
of
an
them will stick. They will
yes,
stick
sir.
together. Stick together, all of them. Try this one.
Velocity also I don't know the expression difference. 36 kilometer kilometer per second. No, the loss is only due to the first of all, when the velocity after the current.
Are you getting it?
Option B says 60 joules.
Option B. So can you just explain the process equations what you have written?
Sir, after the collision, I am assuming we have a common velocity, sir. Then we
Yes.
can, by applying the conservation of momentum, we get the velocity, sir. When
Yes.
loss in energy means initial minus final mass.
Okay, got it.
So
Yes,
initial
that is
minus
the process. That is the correct process. Now try this one.
particle of mass destroys the speed.
Is this question head-on collision or oblique collision?
The oblique, sir.
Yes, this is oblique.
Sir, what is the meaning of coalesces? The two particle coalesces.
Collides, it is co-accels to on collision means they combine, stick together. Co-accel means stick together. Both combine and become one particle. Both of them stick together.
Yes, I got it. Yes.
Yes. Tell me the answer. Are you getting it?
So the answer is v by v by root 2.
Okay. Can you explain the process, equations, what you have written?
Yes, sir. So for after conservation of momentum only, sir.
Okay. And what is
Then
that equation? Read the equation.
yes, sir. mv I cam plus mv j cap, sir.
Is equal to.
M plus m into v bar, sir. I'm assuming velocity
Hmm.
vector.
Correct. You got v vector. Then after that,
Just need to find the magnitude of velocity mass.
magnitude. That's it. Yes.
Root of
Simple.
I cap square.
Yes.
Ax
Yes.
square plus
That's
b
the
by.
magnitude. That's it. Okay. Try this one.
AB by A plus. Option B is bomb.
Bullet of mass A is 5 V in a large block of mass C. Okay, so this is you are taking as perfectly inelastic collision, right?
Yes, sir.
That is correct. Perfectly inelastic. Okay, this one is little good. You can try this one now. Try this one.
Sir, 15, sir.
Yes, tell me.
D, sir.
Okay, so can you just explain the process, what you did?
Sir, we have conservation of momentum.
So first you applied conservation of
Conservation
momentum.
of
Then
momentum.
what you calculated?
Sir, we can look at the V now, sir, after the velocity of
Okay, after that, what you did?
we can apply conservation of energy, then we can
Okay,
substitution we can get.
correct. Yeah, yes. So conservation of momentum and conservation of energy. Or you can do conservation of momentum and work energy theorem also you can apply if you want.
Yes.
Correct. Now you can see that this topic is there, collision between bullet and the vertically suspended block. This type of questions are asked. So very simple. Whenever there will be collision, the first thing that you have to do is we'll apply conservation of momentum just before and just after. Just before, just after. Just after the collision, what will be the velocity of the combined system, bullet plus the block? Because in most of the question, bullet gets embedded in the block. If that is the case, bullet gets embedded in the block, it means that it is perfectly inelastic collision. And then bullet plus block combined will start with some velocity after collision. That you can find by applying conservation of linear momentum. And after that, And a bullet plus block combined system start with some velocity, so then it will go up to some height. Here you can see it is going up to some height here. Okay, and then it will stop at some height, maximum height it will go somewhere. So now after collision you can apply conservation of mechanical energy. So just two steps: conservation of momentum and conservation of mechanical energy for this type of question. So let's try this question, this one. Quickly just write the equations, tell me the equations. Just tell me the equations.
So the equations can be applying a linear momentum conservation with its velocities after collision.
Okay, after that.
And kinetic energy loss, applying the law of conservation of energy or gain in potential equals to loss in kinetic energy, you can get the velocity,
Correct.
initial velocity.
Initial velocity you have to find v1, right?
Yes, yes. From that we can get measurable to equation.
Yes. What will be the final velocity here?
mv by
Final
m plus m. So small m into v by m.
final velocity. Final here.
Yes, sir. Small m into v by
Here. Here velocity. Not here, just after collision. Final velocity. This one. Look at the diagram.
sir, at last it will be zero now, sir. At some height,
Yes. Yes.
final.
Okay. So go for this question. Try this question. What you will do here?
Sir, question.
Yeah.
Sir, can someone zoom the question?
Sorry.
Sir, can you zoom the question?
Okay. Leave it. This is a very simple question. So leaving it. Going to now JEA question. So let's try this one. Try this one. IIT JEE 2009. Is it visible clearly?
Yes.
Visible clearly or not?
Yes, sir. It is visible clearly, sir.
Okay. Try this
Yes.
one.
Three objects. So the final velocity will be force. So the final velocity of the block will be force. Hello, sir. Sir, force the velocity of the third object.
Sorry.
4 will be the velocity of third object.
What is velocity final?
Force, sir. Force.
4. That is the correct answer. 4 meter per second is the correct answer of this question. Okay. So I have sent you another question.
But both is not visible. Screen share.
Sorry.
So our screen share is not visible.
Okay, 1 minute. Now is it visible? Not visible.
Okay. Now also not visible. Sir.
Okay, 1 minute. Now check.
So now it's visible. Sir.
Okay, try this. This is again IIT JEE 2009 question.
Are you getting it?
I'm trying, sir.
Okay. Are you getting Prabhakar? Got the answer? Not getting?
Hello, sir.
Yes.
Sir, I'm getting following the last part, so trying.
Okay.
So, so two, sir.
Yes.
Option C, sir. Chennai.
Option C. Two. Two collisions, right?
Yes, sir.
That is the correct answer. Two collisions. Okay, let's go to the next then. There's again IIT 2010 question. You can try this one. Are you getting?
I'm taking some 1 minute.
Okay.
Sir, sir, momentum is 3 only, sir. Time taken is 0.7. A, C, sir. Hello, sir. A, C, sir. Hello, sir.
Yes.
Sir, A and C, sir.
A and C. 1 minute. A and C. Let me check. One moment. A and C are correct answer. So only these are the things, these type of questions are asked. Okay. We have covered the concepts. So now you just keep solving questions. So now you want me to start SHM or continue with this topic?
So as you wish, like, we can start SHM.
We can start now?
Yes, sir, we can start.
Okay, so then let's start SHM. So before going into SHM, you have to understand what is a periodic motion. Periodic motion is simply that type of motion which repeats itself after a regular interval of time. Here you have to understand that two things are important here. One is the same motion should repeat. Same motion should repeat. And the second is it should repeat after fixed interval of time. Then we call it as periodic. So for example, motion of hand of a clock, motion of earth around the sun, motion of electron around the nucleus, all these are periodic motion. Their time period is constant. The time taken to complete one or you can say the time after which motion repeats again, that time is called as time interval, is called as time period. So time period is simply the time interval after which the motion repeats again. That is the time period. Okay. And this time period should be constant. So this is a constant interval of time after which the motion is repeated. This we call as time period. For example, in the motion of hand of a clock, the time period of motion of hand of a clock is 12 hours. It is fixed. After every 12 hours, same type of motion it will repeat. So this is about the periodic motion and the time period. Two things we understood. Now let's go to oscillatory motion. So oscillatory motion is a type of periodic motion. There can be many different type of periodic motion. Oscillatory is one of them. But in this oscillatory motion, a particle moves back and forth about a mean or equilibrium position. For example, in case of a pendulum, if you just oscillate it, if you just oscillate it, so about this mean position, it will go this side, it will go this side, okay, this side, then this side. So it will keep oscillating about that mean position. It should be back and forth. For example, this, if you pull this block and you leave it, you will see that the block will go up and down about a mean position. Now, what is mean position? Mean position is that position where net restoring force on the particle becomes zero. Okay, net force on the particle becomes zero. We'll say that position where net force becomes zero, that is the mean position. So in oscillatory motion, the most important thing is that the body should move to and fro, back and forth. Okay.
The two and from front and back only, sir.
Yeah, front and back. Another thing is that oscillatory motion is also periodic, but all oscillatory motion will be periodic, but all periodic will not be oscillatory, because there can be different type of periodic motion. For example, circular motion can be also periodic, but it is not oscillatory. Okay, now yeah, same thing is written here. Every oscillatory is periodic, every periodic is not oscillatory. Now, here you have to understand that when the frequency of the oscillating body becomes very high, means it completes a large number of oscillations in 1 second, then we start calling it as vibration. So that is the only difference between oscillation and vibration. Oscillation, so when frequency is low, we call it oscillation. And the same motion, if its frequency becomes high, if the same motion is repeated many number of times in per second, then we call it as vibration. For example, in case of a guitar, a string of a guitar, we don't call it is oscillating, we say it is vibrating, because it completes a very large number of oscillation in 1 second. So when the frequency is high, we call it vibration. Okay, now we will talk about SHM. So first of all, you have to understand that SHM is also a type of oscillation, but it is a special type of oscillation. And how can we define the SHM? So this book has not written it properly. Okay, so oscillation, SHM is simply a type of oscillation in which the restoring force acting on the body, on the particle, is proportional to displacement of the particle from the mean position. For example, if suppose that this is a wall, this is a floor surface, and here a block is connected with the help of a spring here. A block is connected with the help of a spring. So this is the block. This is the block. And it is connected with the help of the spring. And here this spring has, let's say, spring constant K. And the block is, and in this position, the spring is in its natural length. So if a spring is in its natural length, then what is the net force on the block? Net force on the block is 0. And let's say its position is x naught. Imagine that the block is placed on the x-axis at a point x naught. Now x naught is its mean position, because at this position net force on the block is 0. Now you do one thing, that pull this block to the right side and give it a displacement x from the mean position. So now I have given it a displacement, and this displacement should be a small displacement. So I have given it a small displacement x from the mean position. And you can clearly see displacement is a vector quantity. You can see the direction of displacement. And when it will be displaced this side, the restoring force will start acting on this side. So in this case, a spring force is the restoring force. Why we call a spring force as restoring force here? Because the spring force is trying to bring the block back to its mean position. Are you getting it?
Yes, sir, I'm getting, sir.
It is trying to restore its position. Trying to bring it back to its position. Okay. So, and you already know that this spring force is uh, given by Hooke's law, which says that F is equal to kx, but its direction is opposite to x. So in vector form, if I have to write, then I will write minus k x. This is the and in 1D motion, you know, we don't use vector, we use plus and minus sign. So no need to use here vector, plus and minus sign. You can also remove vector sign here and simply write f equal to minus kx, because plus and minus represents the direction. Here y x, because x is in displacement is in positive, and y minus kx because the force is in negative direction. That's why force is in negative. So this is the governing equation of the SHM, that the restoring force, this is the restoring force. So I am writing FR, R for restoring force, should be proportional to the displacement from the mean position and should be directed opposite to the displacement from the mean position. If this is the condition is satisfied, and if the restoring force acting on a particle is directly proportional to displacement from the mean position and opposite to the direction of displacement from the mean position, then and then only we will say that the motion of the particle is SHM. So this is the governing equation of SHM. If this condition is satisfied, then only you will say that it is SHM. So every time, whenever you have to prove or you have to find that whether this motion is SHM or not, you will find a restoring force and you will see that the restoring force is proportional to displacement from mean position or not. Here, the major mistake that students do is they take it as x coordinate. So this x is not the x coordinate. This x is the displacement from mean position, not from origin, from mean position. You can see here that origin is not the mean position, x naught is the mean position. Are you getting it?
Yes, sir, I'm getting it.
So the most important thing here to understand is that it is displacement from mean position always. Here a student makes lot of mistake. Now I can write that, okay, if f is equal to minus kx, and then by using Newton's law I can say that, okay, then acceleration will be equal to minus k by m into x. Okay, and if you will check dimensionally, this comes out to be omega square x, where this k by m is actually represents omega square, where omega is the angular frequency. So this can also be called as the governing equation of the SH, that we will call motion of a particle as SHM if acceleration of the particle is following this equation. Or we can call this also. Both are represent the same thing. Are you getting? If force will be proportional to x, acceleration will be automatically proportional to x because mass is constant, right? So anyone, either the acceleration equation or force equation, any one equation you can. Now, acceleration equation, I can now write it as, it is d2x by dt square. And omega square x, I can take this side and I can write it as, this is omega square x, and then it becomes now how this omega is coming, that we will discuss in few minutes. You will understand that why this omega is coming here. What is the role of omega? But that we will discuss in few minutes now. But before that, you have to understand that this is the general differential equation of SH. You can write it down. This is the general equation of differential equation of the SH. Whenever you see equation like this, you understand that okay, this particle must be doing SH. Is it clear?
Yes, sir, it is clear, sir.
Okay, now let's go to the next. Now you can see that once we have defined now what is SHM and the differential equation of SHM. Now let's do one thing. Let's take a particle which is going in a circle. Imagine there is a particle going in a circle with a uniform angular velocity. With a uniform angular velocity, omega, in anti-clockwise sense. So here you can see this is going in this direction. In anti-clockwise sense, it is going with angular velocity omega. Is it visible? And
Sir,
at
it is
any
visible.
instant of time, suppose that initially the particle at t equal to 0, the particle was here. Then at any t time, particle will reach here. This is the position at time t. So I'm writing. Or okay, let's check it out. At time t. At time t. And if this is moving with an angular velocity omega, then this angle theta will be definitely theta equal to how much? Omega into t, right? Is it clear?
Yes, sir, it is clear, sir.
Now from here you drop a perpendicular on y-axis, and this length, call it as projection of the particle on the diameter along y-axis. P is the particle, O is the center of the circle, and PM is perpendicular. So let's call OM as the projection of this particle on y-axis. And now write down the equation of this y, where y is simply this length, OM. How much is y? How it is related to radius of the circle? So in this triangle, if you write sine theta, you will get y by a, where a is, let's call it as the radius of the circle, capital A. So from this you got that, okay, y equal to a sine omega t. Y equal to a sine omega t, right? Now this is the equation of projection of the particle on y-axis. Y equal to a sine omega t. Now you do one thing, that you differentiate this equation 2 times. d2y by dt square. Do it. Differentiate it with respect to time 2 times. And you will see that ultimately you are getting minus omega square y. You can do it. Differentiate it 2 times and you get this equation. And you already know that this equation represents SHM. So from here it is clear that when a particle moves in a circular path, projection of the particle on its diameter, that represents SHM. And see from where the omega is coming. What was omega?
Omega was the angular velocity of the particle which is going in a circle. So the particle is not doing SHM because the particle is going in a circle. Particle is going circular motion. But projection of the particle, which is this on the diameter, OM, this projection is doing SHM. If you look at this projection here, Hannah, then you will understand. It is better if you call this point M as projection. From P you drop a perpendicular, that point M is a projection. Look at the motion of point M. As the particle moves in the circle, you will see point M goes like this, comes like this, again goes like this, again comes like this. It is doing SHM. Are you getting it?
Yes, sir, I'm getting, sir.
So from here the omega is coming. Okay, now this is clear.
Yes, sir, now it's clear, sir.
Now try this question. Tell me, are you getting it?
So 1 minute, sir, doing third one, sir. Just
Okay.
Hello, sir. First one,
Yes.
motion of factor is oscillatory, sir, sir. Not in simple harmony.
Okay. First and second are oscillatory, you are saying.
Yes, sir.
Okay. And what about third one?
Yes, it's same equation. The third. 1 minute. Third one is the third one is simple harmonic motion, sir. First one is
Okay.
oscillatory. Second one is also oscillatory.
Second one is also oscillatory.
Yes, sir. No, no, sir.
Think
Second
about
one.
second one.
1 minute. Sir.
Is it oscillatory or not oscillatory?
Separation minus 2. It's not an oscillator. It's a
Because the
translator. We
force
can
is
say.
always in one
Or,
direction, right?
yes, sir. You can say it's a translator motion.
So it is not oscillatory also.
Or a translator.
Hmm.
We can say
That
it
is
as a
correct.
translator motion.
Hmm. Now here, find the mean position for this SHM. Mean position for this SHM. Third one.
Third one, sir. Okay. Main person where the force is 0. So I can say x equals to 0 or mm. So x equals to 2 can be said the main position now, sir, because at that only the restoring force will be 0.
Hmm.
So I mean at x equals to is the main position and 0 is the extreme position we can say.
At x equal to.
2 is the main position and 0 is the extreme position we can say now.
Okay. Try this one. Tell me. Is it visible?
It is visible, sir.
Okay.
And it will be a periodic function. Simple harmonic and all the above also. 1, 2, 3 will be same. Simple harmonic, periodic, and along straight line. Sir, I'm audible, sir.
Along along a straight line or along an ellipse?
Along a straight line, sir.
Along a straight line.
Yes, sir.
Okay. Yes, so that is correct. At any instant, its x and y coordinates are equal, right? So it will be automatically a straight line. And what if they ask you amplitude of the SHM? Then what you'll do?
And then by equating with the formula, we can get omega different. Finding acceleration of the particle.
So whenever there is some linear combination of sine and cos, you can always convert it into a single function of either sine or either cos.
Sir, by
For example, you
dividing by
can see
root
here
2, we
what they
can
did. They
convert.
converted it. Yes,
Yes,
they
sir.
converted it in this form. And now it is very easy to say that what will be the R will be the its amplitude, and it will be this.
Yes.
And it is also easy to understand that okay, it will represent a SHM because it is of the form A sine omega t plus phi. So that is correct. It's time for this question. Try this one. Are you getting it?
Yes, sir. So first one sine 2 omega t is h1 and sine
Yes.
omega t plus is cos 2 omega t is h2.
Second is also SHM.
No, third, sir.
Second
Second one,
is
sir. First and second options are correct.
what about third one?
So it's not an SHM, sir.
Yes.
So
Why
first
it is so?
option
Why
is
it is not an SHM? How can you
sir
say
because
third is not an SHM?
sir in the third I will differentiate.
Mhm. Here you can see angular frequency is different, right?
Yes, sir. Because we get minus omega from some other function I get. That's we can say
Hmm.
it's not an SHM.
That is correct. Now this is the general equation of SHM is A sine omega t plus some constant phi. That is the general equation of SHM. A sine omega t x equal to A sine omega t plus phi. This is the general equation of SHM, where phi is the initial phase. If particle starts from this point, then phi is 0. Here you can see this point. If particle starts from this point, then initial phase is 0. But it is not necessary that particle will always start from this point. In SHM, at t equal to 0, particle can be anywhere. So depending on where is the particle at t equal to 0 and what is the velocity of the particle at t equal to 0, initial phase will change. So now you try for this question. Here, one more important information you have to understand that when this particle completes one revolution in circular path, in the same time, its projection completes one full oscillation, and the projection is doing SHM. So the time period of revolution of particle in the circular path and time period of oscillation of the SHM both are same. Is it clear? Is it clear? Not clear?
Yes, it is clear, sir.
Now, what is the time period of the particle which is going in the circle? Its angular velocity is omega. So, what will be time period?
2 pi by omega times.
So, exactly same for the SHM also, 2 pi by omega. Okay, now you can try this question. Are you getting it? Is it visible? Not visible?
Sir, it
Are
is
you?
visible, sir.
Yeah.
1 minute. Like maximum distance, I can say 6 cos pi t or so.
At a start, the pendulum is at maximum displacement, right? So what you are saying, maximum displacement, we can
The
say,
displacement I'm saying, sir. The
yeah,
displacement equation I'm saying.
okay,
6 cos pi t, sir.
6 cos phi t, yeah, because at t equal to 0, x should be maximum, right?
Maximum, sir. Yes, sir.
So cos equation will come. And why you are saying 6? Are you getting 6 as amplitude?
Yes, sir. Consider statistics. So the given time period 2, no, sir.
Up to maximum 5 centimeter is written.
Oh, sorry, sir. It will be 5 cos, sorry.
Ah, okay.
This is a relation between displacement and time, no, sir. 5 cos.
Yeah. Okay. So 5 cos pi t, right?
Yes, sir.
5 cos pi t will be the relation. Okay, that is correct. Now you can derive, first of all, write the general equation of SHM. Write it. What is the general equation? Y is equal to, or x is equal to a sine. Write the equation of displacement. General equation. What is general equation of displacement? In SHM, you can write y is equal to a sine omega t plus some constant, right? This is the general equation of displacement, you can say, in SHM. Now, if you differentiate this equation, what you will get? Differentiate with respect to time, what you will get? Are you there?
Yes, sir, I'm there, sir.
So if you differentiate this equation with respect to time, what you will get?
So we get in terms of cos, no, sir, velocity.
You will get the equation of the velocity, right? And then again you differentiate, you will get the equation of the acceleration. That's it. So once you know the equation of the displacement, you can get the equation of velocity and the equation of the acceleration as a function of time and as a function of displacement also.
Displacement. Yes.
So you can see this equation here. Look at this. See the first one, displacement equation. After that, they differentiated. Then you got this equation. It is
Yes,
as a
sir.
function of t. But you know cos can be written as 1 minus sine square, right? Root under 1 minus sine square. Ultimately this. So tell me, you understood this derivation or not?
Sir, I understood. So the derivation of displacement everything.
So
Understood.
finally, this is the equation of v as a function of y, where y is displacement from the
Uh,
mean position.
yes, sir.
Okay, so you got this. Exactly same thing you can do for the acceleration also. You can here look at the graph. You know that the velocity and displacement equation are out of phase because one is sine function and another is cos function, right? Look at the equation and this equation. This is a sine function, whereas this is a cos function. So look
Cost
at
function.
their graph also.
Yes, sir. Like sine and cos graph only there.
Now again, this will be a sine function, but minus, you know, so the out of phase. This and this are out of phase. Pi radian out of phase. Because here sine omega t, here minus of sine omega t. Are you getting? So how minus will come when you will write sine pi plus omega t? Are you getting? Or pi minus omega t. You can write it omega t plus pi. So there is a phase difference of pi radian.
But what is definite exact meaning of phase difference?
Sorry,
Sir, what is the exact meaning of phase difference?
phase difference is
It's angle difference.
phase is simply like, but here you have to understand that when we say phase difference, what phase difference between what you are talking. So, for example, if we, you know, two particles are doing SHM, and then you are asking what is the phase difference between the two particles which are doing SHM. Phase simply represents the state of motion. For example, two particles are there which are doing exactly same type of motion. Exactly same means same position at any time and same direction of motion at any time. Then we say both of them are in same phase. Same position, same direction. Suppose if this is the mean position, this is the mean position, and you can say both the particles are exactly at the same distance from the mean position, right? This is the distance from the mean position, right? Same. And their direction of motion is also exactly same. Then the two particles are doing oscillation SHM in the same phase. But now, if suppose second motion is that one particle is going like this and another particle is going like this at the same time. Now they are completely out of phase. Or you can say 180-degree out of phase, just reverse. Same position, not same position and not same velocity. So if position of this is -2, position of this is +2. If velocity of this is -4, velocity of this is +4. They are out of phase. That is represented by their equation. So for example, suppose it is y equal to a sine omega t. And another SHM is y equal to a sine omega t plus pi by 3.
And mathematically now you can say there is a phase difference of pi by 3. Means this SHM and this SHM, everything is same. Both of them are doing say SHM of amplitude A, SHM of time period 2 pi by omega, SHM of frequency omega by 2 pi. Everything is same. Then what is difference between them? Difference between them is that their phase is different. What is the meaning of phase is different? The only meaning is that at different time they have different position and different direction of motion.
Sir, sir, I'm not getting the actual case definition. The screen sharing has been stopped.